So in previous video, we actually explained the algorithm of how to solve this problem using heap sort. Okay, this problem is a LeetCode912.Sort an algorithm. So for this video, we are going to continue coding for the heap sort. Okay, so if you want to see the explanation of the algorithm, you can actually check out my previous video. So I have a separate video to explain the algorithm, and here has an example and how to exactly do the max heap and how to remove the nodes, and then the time complexity, and also why the time complexity is ON. This is my previous videos talked about. So for this video, I'm going to actually code. Okay, so using Java. Okay, so let's code. So first, what we do? This one. Okay, so what we do? We need to actually write a function. It's called a heap sort. Okay, we write this function and then return amps. Okay, so let's start from here. Let's start run this one. So this function heap sort, and then input is array, integer array. Okay, yeah, here, and then first we define n, right? Is n is the length of the array. Okay, and then what we do, we are trying to build the heap. Okay, build the heap. Okay, how do we do this? So here is the n. Okay, and then we write another function. It's called a build the heap. Okay, how do we do this? Here is the array. Here is the length. Okay, it's gonna be like this. Okay, it's going to be like this. Here is int n equals to array dot length. Okay, and then we define the start. We start from the last element of the array. Okay, so the last element of the array, the our index, it is like this. Okay, so this is what we are going to do. So we are going to write a for loop. Okay, we are going to write a for loop. Here is the int I from start. The start is the n of 4 because we are doing bottom up. We are using bottom up approach, right? So here, and then I greater equals to 0 and I minus. Okay, this is what we do. And then we happify. So we just happify. Happify is kind of a shift down. I mean, like we are trying to compare the roots and the child. Okay, so happify. So here we are going to actually write a function of happify and to see exactly how happify works. Okay, so it's gonna be like this. This is another method. Okay, what we do, we are doing this. Hey, p5. Here integer, here's array, and integer n, and integer I. Okay, and then what we do, we just define. This is the left child. Actually, we talked about this. The left child knows index is 2 times the parent's index plus 1. So here it's going to be 2 times I plus 1. This is left child. Okay, so the right child is going to be 2 times I plus 2. Okay, this is a right child. Okay, the definition actually is okay, let's do this way. Okay, and then we have a current. We have a current. We let the I initialize the current with I, and then what we do, we will check if the left smaller than n. We have to check the left smaller than n because if in our leaf node, okay, leaf node, the left and the left child and the right child is not exit, right? So it's gonna be greater than the n. N is the size of the heap. Okay, so it's going to be like this. Check if L is there or not, and then what we do this and compare this with the array current. Okay, current right now, current is I, right? So if the left is greater than the I, and the I is the one we are going to check, right? So if greater, then what we do, we make the left equals to current. So we update left to the current, right? So that means that the current is not I anymore. Okay, so and also we need to check if the left if the right smaller than n and array check the right greater than the current. So let's see here. So we check we first check the left with the current. Current right now is I, right? So if it's greater, and then the current become the left, and then we check right greater than the current. If greater, then we update the right to the current, or if not, then our current is left. Okay, yeah, this is basically the logic. The logic is here. Okay, this one gonna be right. Okay, and then if let's see we update the current or not. If if the so initially the I equals to current, right? I equals to current. So if the left or right both are not greater than the current I, then we don't update our current. So we are current still with the I in this case. And then if it's not, the current is not, if the current equals to I, that means we don't have to update anything. That means our current one is greater than the left child and the right child. But if we already updated, then we need to swap. Okay, so here, current not equals to I. Okay, if it's not equals to I, what we do, we are doing int temp equals array, this current, and the array, current equals to array I. Okay, and then I equals to temp. It's like we are we actually just swap the current and I. So we new temp this variable, and we put the array current, put it here, and then we update our current with array I, and then the temp give it to this one. This is kind of a swap current and I. This is the code, and then we do happify happify this n and current. Okay. Yeah, after we swap, and then we do again the current. We start from current, and then we're trying to do it's like this. Like let's say for example, this one. I mean, if here is 5, here is 2. So first we check 2 smaller than this one, the 5 greater than, then we swap, and then we check the 5 greater than this or not. So that means that that means here, okay, the current, we update the current, and then we do happify again, okay, until it's kind of everything is swapped, okay. Yeah. This is kind of the problem. This kind of the function of a happify, right? So this is a happify, but let's see here. See, we start from do that from the happify. Build the heap. Start from the last node, last element of this array, and start from there. We do happify, and then we loop again. So basically, we checked each single nodes of the tray. We actually did a happify, right? So this part is kind of the max heap. So the root of the heap is gonna be the largest one after we do this, okay. And then let's continue the heap sort, okay. So first we build the max happify, right? Create the max heap. Okay. After we created the that one, so what we do, we are going to run a for loop. We are going to remove the element, right? We are going to remove the last nodes. So first we swap the root with the last node, and then we remove the last node. That means we remove the largest element in this heap. Okay. So what we do, we start from I equals to n minus 1 and I greater than 0 and I minus minus, okay? Yeah, we start from here, and then what we do, we start from this array 0 and array 0 equals to array I. Okay, array I. This is array I. We give the temp to the array. So this part actually we swap the array 0 and array I. Okay, so kind of we did a swap here. Okay, and then now we I minus minus, so I minus 1. That means, and then we are for loop another. We are for loop the another element. Okay, so we do happify array I 0. Okay, yeah, let's run the code. Let's try to run the code. Okay, it's accept. Okay, let's give another example. Okay, it's also accept. Okay, let's submit the code. Okay, our algorithm is faster than 63% of Java Online submission of sort of an array. Okay, this is a coding for the heap sort. Okay, so if you want to check out the algorithm implementation, please check out my previous videos. So I have two videos. So one is talking about the algorithm, the heap sort algorithm, and this one is for the Java code explanation. So this is the procedure of the heap sort algorithm, and then the property, and then how to calculate, how to compute the left child nodes index, right, and this is the parents index, and then here is the example I just did how to do it. Okay, and then the time complexity is on, and here is the example how to calculate, how to prove with on. Okay, so it's here. Okay, thank you for watching. I will see you next time.